IXIA, a leader in performance analysis solutions, presents the IxNetwork video tutorial series. IxNetwork is IXIA's flagship software application for testing the network infrastructure, including all devices like routers, switches, network access controllers, broadband access, carrier Ethernet, and data center Ethernet. It's used by professionals around the world, including development and system test engineers, network design and support engineers, and even marketing and sales to demonstrate product capabilities and performance. This video tutorial is brought to you by the IxNetwork product management team.
In this IxNetwork tutorial video, we're covering the Advanced Traffic Wizard. The tutorial is broken up into 5 different chapters. In Chapter 1, we will cover basic terminology that is used within the IxNetwork framework. This will cover the explanation of items such as traffic items, flow groups, flows versus hardware streams. In Chapter 2, we will look at a sample use case and we will explain the test topology. It's a simple IPv4 packet forwarding test where we have 4 IXIA ports connected to a device under test with and without VLAN encapsulation. In Chapter 3, we'll jump into details on the Advanced Traffic Wizard. We will spend time in explaining the endpoint configuration options within the Traffic Wizard, the enhancements that have been made to the QoS configuration, how to enable flow tracking, rate and frame size setup, packet previews, and configuration validation for the wizard run that has just been completed. In Chapter 4, we will spend some time on flow group setup. This is a key concept in the IxNetwork 540 release, and we're going to dedicate a chapter to this specific piece. In Chapter 5, we will go through a more complex use case where the test objective is to validate service differentiation on a device under test. We will explain the test topology, how to configure service differentiation within IxNetwork, and how to go about analyzing the results within the application as well. Chapter 1. Terminology. As seen in this diagram, there is a distinct hierarchy in the different elements generated by the IxNetwork traffic wizard. The highest level of hierarchy is the traffic item. Each traffic item is generated by a single run of the IxNetwork traffic wizard. Each IxNetwork test can have one or multiple traffic items. One level down from the traffic items are the flow groups. Each traffic item consists of one or more flow groups. Each flow group represents packet flows with the same traffic profile, including the same frame size, frame rate, and packet content. The content based on which flow groups are packed or set up together is user defined. We will cover this in more detail in further chapters where we discuss flow group setup. Each IxNetwork configuration can scale up to a maximum of 16,000 flow groups within a particular test. Each flow group in IxNetwork corresponds to one or many hardware streams, also known as IX Explorer streams. Hardware streams are not exposed in IxNetwork. Each flow group in turn consists of one or many flows. Each flow is representative of a uniquely tracked or identified PGID. An IxNetwork test session has the capability to scale up to 4 million flows within a single IxNetwork test. The IxNetwork 540 release lets users configure traffic in one of 3 ways. You can use the quick flow groups to generate quick L2, L3 traffic. IX Explorer style UDF support is provided within this quick flow group view. However, the quick flow groups are not integrated with the routing, switching, or MPLS protocols, and all configuration options that deal with learning specific information from the control plane is not supported with quick flow groups. There is also limited traffic tracking with the quick flow group setup. The next level of hierarchy up is the basic traffic wizard. The basic traffic wizard can be used for routing, switching tests, which are not complicated in terms of the topology. This traffic wizard is integrated with protocols, and things like MPLS label learning and route learning is supported with the basic traffic wizard. There are options to support ingress tracking, however there are no options to set up flow groups and advanced QoS capabilities. The Advanced Traffic Wizard is the most powerful of the 3 configuration options and should be used for complex multicast, routing, and MPLS related tests. The Advanced Traffic Wizard can also be used for tests where there are mixed encapsulations supported within the specific configuration. There are detailed packet and QoS capability and configuration options within the Advanced Traffic Wizard which are not exposed in the quick flow groups and basic wizards. There are capabilities to set up flow groups within the advanced traffic wizard, which let users control options like rate and frame size based on packet content as created by the config. There are also detailed ingress and egress tracking options available with this advanced wizard. Chapter 2. Use Case 1. This test is an IPv4 forwarding test, and the objective of the test is to validate the duct IPv4 performance when layer 3 traffic is sent to it. For the test setup, we have 4 Ixia ports connected to a device under test. Of these 2 Ixia ports, there are 100 IPv4 endpoints configured across 10 VLANs on one port pair and 100 IPv4 endpoints without any VLANs configured across the other pair. Within the test, we will use the advanced traffic wizard to configure the traffic mapping across these port pairs. We will create 2 separate endpoint sets for each encapsulation type, one with and without VLAN encapsulation, and allow the user to configure the traffic properties for each endpoint set. We will then go in and enable tracking options for VLAN ID and for each particular traffic item. The objective of the test is really to send untagged traffic and tagged traffic to the device simultaneously and validate the performance of the device under test. Chapter 3. The Advanced Traffic Wizard. In this chapter, we will go through details on how to configure the IPv4 forwarding test as described in the previous chapter. The first step in this operation is to add the 4 ports that are going to be involved in the test. The Port Manager tab within the IxNetwork GUI is where the ports involved in the test are added. Within the screen, you come to Add Ports, and then you add the ports that are essentially going to be a part of the test. The second step in this configuration process is configuring the IP addresses and VLANs for the static IPv4 endpoints that are going to be used within the test. The 4 protocol interfaces used in this test have already been configured with IPv4 addresses, and for the second port pair, they've been enabled with VLANs as well. If you look at ports 113 and port 114, you will see that there are static IPv4 addresses already configured on these 2 ports without any VLANs enabled. For port pair 15 and 16, there are VLANs enabled for the 100 IPv4 endpoints which are emulated by the Ixia ports, and the 100 IPv4 endpoints are spread across 10 different VLANs. The next step is to launch the traffic wizard to create the traffic mesh between the source and the destination endpoints. To launch the traffic wizard, click on the Traffic tab on the left navigation pane and launch the Advanced Traffic Wizard. The Advanced Traffic Wizard can be launched one of 2 ways. It can be launched by clicking on this Advanced Traffic Wizard button present in the grid, or it can also be selected from the drop-down that is available within this left menu icon. So I'll launch the Advanced Traffic Wizard. The Advanced Traffic Wizard in IxNetwork 540 is broken up into a number of sub-navigation panels. The user at any stage can go to a specific option within this navigation panel and configure the properties for the specific endpoints that are being configured within the test. In this particular example, all my endpoints in the specific system are IPv4 endpoints. My type of traffic in this particular case is IPv4. The type of traffic in this case is essentially a filter to let you filter out endpoint types which are not of interest for this run of the traffic wizard. For instance, in this particular example, I do not have any IPv6 endpoints configured within the test. So if I go in and select an IPv6 endpoint, I will basically see that there are no endpoints associated with this specific type of traffic. So in large-scale topologies and configurations where there is a mixture of IPv4 traffic mixed with IPv6 traffic, these filters greatly help in filtering out the unwanted endpoints within a traffic item. So for this example, I'll go back to the IPv4 endpoint. You can give the traffic item a name. In this particular case, I will call it IPv4 forwarding, since that is the name of the test. We'll now let you enable in 540 bidirectional traffic. So if you're interested in traffic in both directions, from source, from transmit port to receive port, and back from receive to transmit, you can click the bidirectional checkbox and traffic will be sent in both directions. In this particular test case, my first traffic endpoint is going from the first 100 IPv4 endpoints which are emulated on port 1 to all the IPv4 endpoints emulated on port 2. This is the untagged traffic that is going to be sent. To apply this particular traffic or to create the traffic endpoint, you then come in and click the apply button. This creates what we call an endpoint set within the IxNetwork traffic wizard. Each endpoint set can have one encapsulation type, and the properties within the traffic wizard for each endpoint set can be controlled individually. This will become clearer as we go through the next few steps within the traffic wizard. The second endpoint set which I'm going to add is for the VLAN encapsulation. This is the traffic being transmitted from port 115 to port 116, which has the VLAN tag traffic or the VLAN encapsulation on these protocol interfaces. Once these two endpoints are selected, you can then click the apply button again, and it will create a second endpoint set with the VLAN encapsulation. IxNetwork 540 lets you do mixed encapsulations within the same run of the traffic wizard and assign them to different endpoints so that you can individually control the properties of each endpoint. I'm going to come in here and name each endpoint set so that it's more user friendly. You hit F2, specify the name of the endpoint. I'll call the first one IPv4. You apply the name for this particular endpoint set, and for the second endpoint set, I'm going to call it IPv4 and VLAN. Now once these endpoint sets are created, I can go to different pages within the traffic wizard and specify individual properties such as rate and frame size for each individual endpoint set. The next step in the configuration process is the packet and the QoS tab. In the packet and the QoS tab, the user has a detailed view into the packets that are being sent out on the wire for each endpoint set that has been created from the endpoints page. In this specific case, if you click on the endpoint set which is IPv4, you clearly see the packet contents which are going to be sent out on the wire for this particular endpoint set. You have the option to expand all the protocol headers within the particular packet and look at the detailed packet content. The same applies to the other encapsulation type or endpoint set in this case, which is with IPv4 and VLAN, which will also give you the detailed packet contents for that endpoint set. So with the creation of different endpoint sets which have different encapsulations, you can in the packet view get the detailed packet content that is being sent out on the wire. In this particular example, as you can see, for the second endpoint set which is IPv4 and VLAN, we see a VLAN header with the VLAN information already populated in this particular set. For this packet, for the QoS configuration, the QoS editor has significant enhancements in 540. Within the same run of the traffic wizard now, for the IPv4 endpoint for instance, you can specify multiple QoS values. You can either specify them as a raw priority, as a toss value, which has the predefined values as specified by the standards. So I'm going to specify a value of 000, a value of 1, a value of 5, and a value of 7. So within the same run of the traffic wizard, you can actually specify multiple QoS values as well. What this will do is it will send these 5 QoS values between the source and the destination endpoints. Now for the user to be able to fully mesh these QoS values between all the source and destination endpoints, you need to come into the packet editor, click on the precedence field in this particular example, and indicate that you want to fully mesh this field. What this means is for each source and destination IP endpoint for which traffic is being sent, all the QoS values will be cycled for that particular endpoint set. So I'm going to fully mesh this field in this particular example. So as you can see, I also have the capability here to specify diffserv values with all the predefined standard values for diffserv as well. For the second endpoint set, you have the capability in this particular example to say for the L3 QoS values, I want to copy the values that are from the VLAN QoS values as well, or the VLAN cost bits. So what the QoS view lets you do is copy priorities from one level of encapsulation to another. So in this specific case, I'm going to say for endpoint set IPv4 and VLAN, actually copy the L3 toss values from the VLAN user priority. The VLAN user priority values were specified in the actual interface configuration. You also have the option to come within the specific packet editor and overwrite the priority values that you specified within your IPv4 endpoints in the protocol interfaces. So in this specific case, I'm going to say copy the L3 toss values from the visa priority. As an added example, for instance, if there is an MPLS encapsulation as a part of this endpoint, you then have the capability to say you want to copy the MPLS EXP bits based on the L3 toss values, or you can want to copy the MPLS EXP bits from the L2 toss values. So there is complete flexibility within this packet editor view and this QoS view to specify multiple QoS options. So now that I've copied the values from the VLAN user priority, I will click OK. And it clearly states here within the grid that the values are essentially being copied from the VLAN user priority. So the packet and the QoS tab gives you a lot of flexibility in specifying QoS values. In addition, if any additional packet manipulation if the user wants to perform any additional packet manipulation, it can be done in this particular view. You have the option to add another protocol frame. IxNetwork ships with a number of predefined packet templates, and any of these packet templates can basically be added into this view, into the particular packet, and that's what will be sent out in the wire. There is also capability to look at this in terms of easy to look at stack diagram, where you can come in here. In this particular case, I have an Ethernet VLAN and IPv4. You can come in, you can add another protocol template, which is TCP or UDP. So in a sense, you can create any packet type that you want within this specific tab. The next configuration step is the flow group setup. In this run of the traffic wizard, for both the encapsulation types involved in the traffic test, I will say I do not want to do flow group setup based on any specific attribute. We will revisit this after the next chapter, where we describe service modeling, to see how selecting an option per endpoint set in this particular view impacts how the flow groups are generated within the IxNetwork test. The next configuration option is the frame setup. In the frame setup, you actually come in per endpoint set, or you can select all the endpoint sets that are configured within this run of the wizard and specify the frame size that you want to send for the traffic. In this example, I'll specify a frame size of 512. You also have the option to specify incrementing frame sizes from a starting frame to an end frame with a step size for each increment. You have the option to do random values and specify a minimum value and a maximum value. You have the option to do iMix traffic, where you can specify different weighted pairs. There are a bunch of predefined distributions which are included as a part of the IxNetwork 540 release, but you also have the option to go in and define your custom pattern as well. As far as payload is concerned, you have the option to increment a byte in the payload, decrement byte, or you can do a random payload option as well. As far as CRC goes, you can specify whether you want to send a bad CRC in the frames that are going out, you want to send no CRC or error. In this particular example, like I said, for both the endpoint sets that I have configured, I'm going to specify the same frame size of 512 bytes. The next configuration option is the rate setup tab. As in the previous tabs, you have the flexibility to specify the rate per endpoint set, or you have the capability to specify the rate across all the endpoint sets. There is a traffic item transmission mode associated with every traffic item created within the wizard. This lets users have the flexibility to specify the TX mode per traffic item as interleaved or sequential, and this does not necessarily need to align with what you have configured within the port manager. If there is a mismatch between the traffic item transmission mode and what is configured in the port manager during the application of traffic, the user will be warned about the fact that there is a mismatch in the TX mode. What this lets you do is specify multiple traffic items in different transmit modes, and based on the specific test that's being run, you can switch the modes of the ports between interleaved and sequential without having to recreate your traffic item. As far as rate goes, in this specific example, I'm going to specify a line rate of 10%. And as far as rate distribution goes, the users have options to specify the same rate on all the TX port involved within the test, or do you want to split the rate that we've specified here across all the TX ports which are configured in the traffic item. The same options are basically applied towards the flow groups. If you have one or many flow groups created within a specific run of the traffic wizard, you have the option to specify that you want the rate distribution to be split evenly across all the configured flow groups or generated flow groups, or do you want to apply the same port rate to all the flow groups. As far as packet transmission goes, you have these You have various options to control the packet transmission. You can do continuous packet. You can specify a fixed packet count, which lets you stop after one packet or n number of packets. You have a fixed iteration count, which also lets you do specify a fixed number of packets and run them for a specific number of iterations. You have the options to do bursty traffic as well. For this specific example, we'll make the packet transmission mode as continuous. The next configuration option is flow tracking. Within the flow tracking tab, we allow the user to specify the criteria on which they want to track the flows that are being sent as a part of the traffic mesh. In this specific example, we will track the flows based on VLAN ID and based on IPv4 destination address. As you can see, by default, the traffic item tracking is always enabled. Tracking multiple fields, which is a new feature introduced in the IxNetwork 540 release, gives you tremendous flexibility in viewing the statistics at different levels of aggregation. As an example, the highest level of aggregation within the statistics view is the traffic item. It is a single one-line view which will give you statistics for all the endpoints associated within that traffic item. The next tracking option that we picked here, for instance, is VLAN ID. What this will do is give you a level of aggregation per VLAN ID for across all the IPv4 source and destination endpoints within the system. In this particular example, we've configured 10 VLAN IDs. So enabling this tracking option, which is VLAN ID, gives you an aggregated statistic for all IPv4 source and IPv4 destination addresses across the 10 VLANs. The fact that the IPv4 destination address has also been enabled as a tracking item, the user then has the flexibility to drill down per VLAN ID into a specific destination address. This will be clearer when we get into the statistics section as well. This specific window which says track flows by is tracking on ingress values, which is basically the tracking on the TX ports. There is an option available within the traffic wizard which is egress tracking, which lets you monitor receive traffic on the receive port. This is particularly important in cases like QoS remarking, which is covered in another IxNetwork tutorial video, where you want to validate any kind of QoS remarking that might happen on the device, where IxNetwork is transmitting one QoS value, and based on certain policies or rate policies configured on the device under test, the QoS is going to get remarked to another value. In this particular example, we're not going to look at the egress tracking because I'm not doing any QoS remarking. You also have the capability to enable latency measurements. What this does is it gives you this concept of latency bins in IxNetwork, which gives you detailed latency distribution across a number of buckets that you can specify within the IxNetwork GUI. We can scale up to a maximum of 16 buckets within the specific IxNetwork config, and you also have the option to specify the step sizes for each bucket. The flow tracking window also gives you an approximation of the resources that are currently used because of enabling various tracking options. There are 20 bits available within the Ixia hardware to be able to track a number of flows, and based on the tracking options that you use, this resource indicator gives you an approximation of how many bits of the 20 available bits have you used. Based on whether you select ingress or egress tracking, this will update in real time to give you an approximation of resource usage. If at any stage you exceed the number of bits that are being used, network will basically flag you that you don't have enough hardware resources to be able to track all the different fields that you want to enable in the flow tracking page. The way to work around this, or the way to fix this problem, is to uncheck a few tracking options so that some of the bits are essentially freed up. The next view within the traffic wizard is the preview tab. The preview tab gives you a preview of all the packets and packet contents that are being sent out on the wire. You have the capability within this view to see all the packets sent out as a part of this traffic item or across all the traffic items configured within the system. If you come in and click on the view flow groups and packets, this is actually doing the learning process in terms of resolving destination MAC addresses in this specific example. So if you look at the detailed packet contents for the first flow group, which is going from TX port 113, which is sending the untagged traffic, since I had fully meshed all the precedence values, for each source and destination address pair, it is sending every single QoS value that I had configured, which is a value of 0, 1, 5, and 7. for the second flow group that's going out on the wire, if you remember, we had copied the precedence value for L3 toss from the VLAN user priority. So the VLAN user priority and the precedence values are in sync. So we're sending a VLAN user priority of 1 with a VLAN ID of 1. And if you go further down and navigate the packets that are in the tab, you will see that the L2 and L3 QoS values are exactly in sync. So this view gives you a very clear indication of what is actually being sent out on the wire as well. The next tab is the validate button. This is a new option added in the IxNetwork 540 wizard, which essentially lets the user validate their configuration. When you validate the current config, you can do it for the present traffic item or across multiple traffic items. When you validate the config, the GUI IxNetwork is essentially going behind the scenes and validating whether you have enough hardware resources to achieve the scale that you have actually configured as a part of this wizard run. It gives you a clear indication of whether your configuration is valid, and the different checkboxes here indicate you have enough hardware resources to send out all the packets that you want to send out on the wire, which basically means you have enough space in your UDFs. You have enough hardware streams essentially available on the Ixia hardware, which basically means you have enough hardware resources to configure all your flow groups. And as far as tracking is concerned, it means you have enough PGIDs to be able to track the complete mesh that you're sending as a part of the traffic item. If at any stage one of these is not a valid or a supported configuration, or it's something that cannot be accommodated as a part of the hardware resources, there'll be a clear error or a warning message within the specific tab to indicate what the error is and how a user might go in and address this particular error. Once all these configuration options are finished within the traffic wizard, you can go in and click finish, and this will actually go into the IxNetwork GUI and populate the traffic grid. Once the wizard run has completed, in this case there are two flow groups which are generated in the IxNetwork traffic grid, one flow group for each endpoint set. So as you can see, there is one flow group for the IPv4 endpoint set and one for the IPv4 and VLAN endpoint set. Each flow group has the capability and the property such that you can change the frame size and frame rate on the fly when traffic is running. We will go ahead and apply this traffic to the Ixia hardware. During the application of the traffic, the statistics views are created within the IxNetwork stat viewer, and the actual configuration is pushed to the Ixia hardware. So once the traffic is applied, you can come in, start the traffic, navigate to the statistics tab. IxNetwork 540 introduces a number of new stat views. For instance, the data plane port statistics view is an aggregated view for all the ports that are basically present within the system. It gives you a transmit count, a receive count, and frame rates for each of the ports involved within the test. The next aggregated view available is the traffic item statistics view. What this view basically does is it gives you an aggregated statistic for each traffic item configured within the test. So in this specific example, I have one traffic item configured, which is IPv4 forwarding. So it gives me an aggregated stat for transmit count, receive count, any frames that are lost on the wire or might be in transit, a loss percentage as well, and frame rates. It also gives you an indication of all the latency values as the packets make their way from source to destination. Now, in the traffic wizard, we had picked tracking options based on VLAN ID and IPv4 destination address. What IxNetwork 540 now lets me do is drill down from an aggregated view in real time without stopping the traffic to one level or multiple levels of aggregation based on the tracking options that I picked. So for instance, in this example, for this traffic item, I can say, show me the statistics per VLAN ID. So this is a real-time drill down that now lets me enable traffic statistics per VLAN ID. So now, as you can see in this particular case, I have aggregated counts across all IPv4 source and destination endpoints for each VLAN configured within the system. I can now perform a second level of drill down by saying, for VLAN ID 2, show me all the IPv4 destination addresses associated with this particular VLAN. That's the second level of drill down that I can do. Now this level of drill down then gives me an indication of all the IPv4 destination addresses that are essentially tied to VLAN 2. This real-time drill down feature is a very powerful feature introduced as a part of the IxNetwork 540 release, which gives the user multiple levels of aggregation within the GUI. As you can see, this test objective has been met because the DUT is basically forwarding traffic without any loss. You can come in right now, and for each flow group you can come in and go ahead and change the line rate from 10% to 100%. Again, this is rate change on the fly. You can come in, do a grid operation, and say you want the same rate for both the TX ports. So in this particular case, you will see that even when you're transmitting at line rate, the device under test is forwarding all the traffic. So you have successfully validated using the aggregated traffic item statistics and the configuration run through the traffic wizard that you've met the test objective. Chapter 4, Service Modeling. In this chapter, we will go through key design concepts associated with service modeling. The key need for service modeling is for the user to be able to emulate millions of subscribers with deterministic traffic profiles within a single IxNetwork test. The end user then needs to have the flexibility to be able to dynamically control each profile configured within the test to accomplish use cases such as validate SLAs. In order to accomplish this, the traffic flows within an IxNetwork configuration will be intelligently packed into individual flow groups based on user selection criteria. For example, all traffic flows with the same VLAN ID can be packed into a single flow group, and the user then has the capability to individually set traffic profile parameters like frame size and frame rate for each of those flow groups. In the IxNetwork 540 release, the available flow groups per port will go up from 256 per port to 4096 per port, which allows users to emulate up to 4096 different traffic profiles simultaneously. The intelligent packing and traffic parameter settings are done within a single run of the IxNetwork traffic wizard today. This is extremely efficient and scalable comparing with any other test tool out there on the market. We will now explain flow group setup and service modeling with the use of an example. If you have an IxNetwork configuration in which you have 3 endpoints configured within the traffic wizard, each endpoint now has 3 VLANs associated with the endpoints: VLAN 1, VLAN 3, and VLAN 5. Each VLAN can have a different number of IPv4 endpoints associated with the VLAN. If the flow group setup option selected in the traffic wizard is none, then 3 flow groups will be written out, one for each endpoint set. So you will get flow group 1, flow group 2, and flow group 3, each associated with the endpoint. The user then has capability to be able to control traffic profiles per endpoint set. If you look at the same example where the user essentially configures 3 endpoint sets within the IxNetwork traffic wizard and has the same VLAN IDs and number of users associated with each endpoint, and then for traffic distribution control or flow group setup, the user selects VLAN ID. In this particular example, IxNetwork will intelligently pack all the endpoints across VLAN 1 into a single flow group, all the users with VLAN ID 3 into a second flow group, and all the users within VLAN ID 5 into a third flow group. These flow groups will be further broken down then by endpoint type. So the user will now have granular control in terms of rate and frame size per VLAN per endpoint set. So in this specific configuration example, the IxNetwork configuration will consist of 9 different flow groups per VLAN per endpoint set, so that the user can then validate SLAs and change rates based on VLAN ID to check conditions of oversubscription to make sure that if there are service level agreements in place which dictate that VLAN 1 has higher priority traffic than VLAN 5, you can easily control the rates per VLAN per endpoint set in the IxNetwork traffic config. For the configuration example used in Chapter 2, we had set the flow group setup options to none. As a result of this, there are flow groups created per endpoint set in the traffic wizard, one for endpoint set IPv4 and one for endpoint set IPv4 in VLAN. If you go back and re-edit the traffic item that was generated in the previous run of the wizard, you can come into the flow group setup page. Now in the flow group setup page, you have the capability to set grouping options per endpoint set. So for the IPv4 and VLAN endpoint set, I'm going to select flow grouping based on VLAN ID. If you then go back to the IPv4 endpoint set, or the IPv4 encapsulation type in this case, you will see that the options based on which you can group your flows changes based on the encapsulation type. For the IPv4 endpoint, I will do flow group setup based on IPv4 precedence. When you click finish, IxNetwork will now generate flow groups for each endpoint set based on the options picked to do the grouping by. So for the IPv4 and VLAN encapsulation, you will see individual flow groups for each VLAN configured within the system, and for the IPv4 endpoint set, you will see flow groups essentially set up for all the precedence values configured within the system. So for IPv4, you have 4 separate flow groups, one for each precedence value configured, and for the VLAN, you have a separate flow group for each VLAN ID configured within the system. The user now has flexibility to be able to control the rate per precedence value across all endpoints within the system. So you can control rate for precedence value of 0, 1, 5 or 7, or you also have the option to come in and change the rate and frame size values on the fly for individual VLANs within the IxNetwork test. Changing the rate for VLAN ID 3 as an example will change the rate for all traffic coming from the endpoints which belong to VLAN ID 3. The user also has the option to come into the traffic grid and change the grouping so that you can look at all the flow groups based on endpoint set. Chapter 5, Use Case 2. The objective of this test is to validate service differentiation based on configured service policies. We expect the DUT to forward traffic with highest precedence with the best performance. For this setup, we are using 4 Ixia ports connected to a device under test configured with appropriate service policies to forward higher precedence values with better performance than lower precedence values. We will use the advanced traffic wizard to configure the traffic mapping, which is a 3:1 scenario. We will then use the flow group setup to intelligently build flows which will allow users to control rate per QoS value. We will then enable tracking per QoS value and source and destination IP. This will enable users to view statistics detailed per QoS, per source IP, per destination IP, or a combination of any of these fields. We will then start traffic and not oversubscribe the receive port, in which scenario we should see no packet loss. We will then use the rate change on the fly to oversubscribe the receive port and use the drill down views per QoS value to validate that the DUT performance and policing is working in a condition of oversubscription. The first step in the configuration process is to add the ports to the IxNetwork config. As you can see, I've already added the 4 ports which are going to be used as a part of the test. To emulate the topology represented in the topology diagram, we will use OSPF on the first 3 ports to advertise a mixture of routes to the device under test. These have already been configured in this specific configuration, with each OSPF router advertising 3 route ranges each with a different number of routes per route range. Once the protocol sessions are up, you can come into the traffic tab and start configuring the traffic using the advanced traffic wizard. Once the traffic wizard has been launched, you can see that the type of traffic is set to IPv4 and all the source and destination ports in the system appear in this traffic grid. There is a clear indication for each port in terms of how many IPv4 endpoints are present on the particular port. So for port 1, you have 350 IPv4 endpoints which are emulated as a result of the 350 routes advertised by the first OSPF router. For the second port, you have 240 IPv4 endpoints which are advertised as a result of the OSPF route ranges, and for port 3 you have 155 different IPv4 endpoints configured as a part of OSPF. The user has the option within the advanced traffic wizard to also come in and quick select particular nodes. What this lets the user do is come in and specify filters to be able to search through a large navigation tree and find specific protocols of interest. So for example, in this particular case, I want to come in and say, show me all the nodes where the protocols equals OSPF. Once you specify the filter, you need to apply it, and the tree view now gives you a filtered list of only OSPF protocols which are configured on each of the individual ports. You can go ahead and cancel this filter I will name this traffic item as QoS. As a part of this configuration example, we will create 3 endpoint sets. The first endpoint set will send traffic from all the routers on port 1 going to the port 4 on the Ixia side, going through the device under test. This is the first endpoint set. The second endpoint set will be all routes from OSPF router on port 2 going to port 4. And the third endpoint set will be all traffic going from OSPF on port 3 going to port 4. So as you can see in this specific example, I've created 3 different endpoint sets. The next step in the configuration process is the QoS configuration. In this particular example, we will set the same QoS or TOS value for each of the configured endpoints. The reason for doing this in this test is because we want to make sure that in a condition of oversubscription where you have multiple transmit ports sending the same QoS value which oversubscribe a particular receive port, that the device on the test is forwarding traffic with the highest precedence with the best performance. So in this specific example, we'll configure 3 QoS values, a QoS value of 7, a QoS value of 5, and a QoS value of 3. Now once you have this configured for one of the endpoint sets, you can come into this top grid, select all the endpoint sets, and say you basically want the same QoS values across all the endpoints. You will now see that each particular endpoint set in the traffic wizard has the same set of TOS values as configured by the first one. If you have many endpoint sets configured within the system, these grid operations to do copy down and same function helps configuration process to be a lot faster. In the flow group setup page, in this run of the traffic wizard, you want to configure flow group setup options based on precedence values. This is because you want to be able to individually control rate per QoS value to make sure again that in a condition of oversubscription, your traffic with the highest precedence is forwarded with the best performance. So you can come into the grid, select all the endpoint sets, and say you want to do flow grouping based on IPv4 precedence. For the frame setup tab, we can leave the defaults. In this case, I'll change the value to 512. For the rate setup, we'll start off with a smaller rate. We'll start off with a rate value of 1%, for instance. So we'll apply the same rate on all the TX ports, which in this case is 3 ports, and we'll also apply the same port rate to all the flow groups generated by the system. Later on, when we actually start running the traffic, we can go in and increase the rate on the fly to oversubscribe the port. In the flow tracking tab, I'm going to enable tracking on IPv4 precedence, IPv4 source address, and IPv4 destination address. We'll go ahead and finish the traffic wizard run. Since flow group setup was picked to be IPv4 precedence, you should see a total of 9 flow groups created within the test, 3 per endpoint set, because each endpoint set had 3 precedence values. You can come into the traffic grid now and do the grouping based on IPv4 precedence. This now lets you control rate for each of the QoS values configured across the endpoint sets. So as you can see, IxNetwork has intelligently packed all the IPv4 endpoints associated with a particular QoS value into a single stream per TX port. So once the traffic wizard run is complete, you need to apply the traffic. This creates the stat views within the IxNetwork stat viewer. Once the views are created, you can come in and start the traffic. In the first case, we are not oversubscribing the receive port because we are transmitting at a very low line rate, 1% across 9 different flow groups, which is a total of 9%. So if you come in and look at the traffic item statistics, you'll basically see that there is no loss. You can also come into the traffic item statistics and view the aggregated statistics per precedence value. These are real-time drill downs that are basically available as a result of the tracking options that you pick. Again, since there is no oversubscription, you're seeing no loss, and the TX and RX counts are exactly the same. We'll now come back into the traffic grid and increase the rate for all the flow groups so that the receive port is in a condition of oversubscription. We'll come into the frame rate, come and increase the rate to 20% for each of the flow groups, which is clearly a condition of oversubscription. In the drill down views for the precedence values now, you will basically see that the precedence value of 3 is being dropped the most, followed by a precedence value of 5, followed by a precedence value of 7. This lets you validate the fact that in a condition of oversubscription, the device under test is essentially forwarding traffic with the highest precedence with the best performance. As you can see, the first precedence value is highlighted in blue, which means that this is a dead flow. It has stopped receiving any traffic from now on. You also now have the option to go per precedence value and drill down and look at all the destination addresses which are affected for that specific precedence value. So using the aggregated views and the real-time drill down views and using the concept of flow groups within IxNetwork, you've easily achieved your objective of the test, which was to validate service differentiation of a device under test.
For more information on IxNetwork, check out www.ixiacom.com. Thank you for your time and interest from the IxNetwork product management team.